Perfect. All right. So on the agenda, I'm going to give a quick presentation on Go as WASI P1, which was released with Go 121 last month, and we also have a blog post coming up tomorrow that's going to kind of like document how to use the text. So this kind of a complement to that. I don't want to paraphrase too much the post, so what I'm going to do is I'm going to do a full like demo style presentation to show how to in practice use like build go to WASI. And with no further ado, I've created a couple of examples in this repository, so you can check it out afterwards. But at the very core, to build an application like a regular Go application in general, you're going to do, I think I've got this little hello.go. So this would be the common way, and then I can run my hello program. But this is native. What we want to do is we want to build the WASM module. So in Go, we can target different architectures and different platforms through environment variables during compilation. So we're going to tell it, compile this to WebAssembly, and then use the WASI P1 OS. So this is the kind of the target platform. And then, I mean, we could call it hello, but it's common to call WASM modules with the .wasm extension. So we'll just add -o here. And now we've got this little WASM module. So obviously we can't run it anymore directly. We have to use a runtime. So we can use runtimes like wasmtime, or zero, wasmedge, or all the derivatives of it. So here, if we do wasmtime run, hello.
Sorry to interrupt. Is it only me that I didn't see the screen?
It's not only you. Okay.
Great.
So now it makes a lot more sense, I imagine. So thank you for interrupting me, Joe. So we can run it with wasmtime, and then our little hello world is working. And WASI P1 is a specification that kind of describes how the WASM module is going to interact with the environment. So you get things like environment variables, random numbers, and then the file system access. But it's in general limited to this. So I've got another little example here, kind of like, a little cat program. So if we build this one, back to my build command. Now we've compiled this little program, and then we can run it similarly. And this is where it's going to start breaking. So intuitively, we're going to think, okay, I'm going to, output the content of cat.go with my cat program. But this doesn't work because the WebAssembly runtimes create a sandbox. So we don't have access to the same, current working directory and like a file system that we have in the shell. So to do this, there's two things that we need to add here. First of all, we're going to have to expose a directory. And here I'm going to expose the root directory just to make things simple. But if we just do this, it still doesn't work because there's no notion of working directory in WASM. But we have, to have most of Go keep working, we have an emulation of the working directory through the pwd environment variable. So if a runtime gives, a value to pwd, the Go program interprets this as the current working directory, and then it will kind of append this path to all the path resolutions, so that now I can print my cat program. All right, so this is, basic kind of like file things that we can do. But as soon as we try to do things that are, that involve the network, which is very common for Go application, right? We're building servers, we're building distributed systems with this language in general. And so this is where it starts to break. So I'm gonna like try something very simple, as just to write a program that resolves github.com. So if I build this, and I try to run DNS then it doesn't work because there's no network in the WASI-P1 spec. But we have a solution in Go, at least, until WASI Preview 2 and all the goodies that come with it is finalized. When we target WASI Preview 1, which is WASI P1 here, we need to use extensions to the specification in order to do networking. So I have an alternate version of this DNS program. And here the only difference is the presence of those lines. So we're going to use this third-party packet, net WASI P1, and we're going to change the dialer for the default resolver. So the default resolver is kind of like a Go implementation of the DNS client, and that's what's being used then by this like functions like lookup host. And so this version of this dial function understands that it runs in a WASI P1, WASM module, and then it uses extension of the runtime to perform DNS resolution or all kind of networking in general. So now if we change, I need to build this first. So if I run this one now, still doesn't work. So this is because wasmtime does not have those extension. It only implements the basic WASI snapshot preview 1 functions. But there are other runtimes like wasmedge or this other project called WASIGO. So WASIGO is a set of libraries to build WebAssembly hosts based on WASIRO. It's kind of like declaring new host functions, and then the project has a couple of predefined extension to WASI Preview 1, including the ones that allow networking in this case. So if I use and there's a little utility that kind of package all of this. It's called WASI-Run. So if I use WASI-Run here, and it's kind of like the same syntax to keep things simple. But now I can do DNS resolution. And this utility is like really cool for debugging when you're working with modules in general, because it's got this trace functionality. And what it does is it prints all the host function calls that the module makes to the runtime. So to like introspect kind of what's going on, it comes very handy in general. But here we can see that it opened a socket, and then it did a connect, extra did the DNS resolution, and eventually printed the result and then called exit. So DNS is cool, but there's a lot more that we can do in general with networking. And this is another example that we've seen people who tried using Go WASI P1 kind of bump into. And so I wanted to mention it, kind of have on record, how to kind of like address those problems. But when you're trying to build a web server, so I'm going to rebuild this. And then I'm going to run it and I'm gonna run it. No trace HTTP server that wasn't. So this breaks, and it breaks with a very weird error message in Go, which is, it says that all Go routines are asleep. And technically, this would be a valid Go program that runs a HTTP server. So it's kind of unexpected that when running it as a WASM module, we're getting this error message. And the reason this happens is because by default, the Go networking stack uses a kind of an in-memory emulation in order to be able to execute its test suite. Now, this in-memory emulation is not useful when we're trying to run a kind of a production application. And because there's nothing going on right now in this program, then Go detects that all Go routines are asleep and then it crashes. So here, once again, we're going to use the same net WASIP1 package and create, in this case, not use the dial function that opens sockets, client sockets, but we're going to use the WASIP1 listen function which is has the same behavior as the standard libraries net.listen, but it uses, once again, extension to the WASIP1 specification to create listening sockets. And with this, we can then run our HTTP server on this listener that has opened a socket through the WASM runtime. So now we try to. I still need to build things. All right. Nothing happens. This is because now the server is listening, right? So the WASM module opened a listening socket on the runtime. The runtime is listening on that socket on its behalf, and it will forward connections into the module to execute HTTP requests. And so now if we go and query it, some port 3030, then we get a response. So this is our little hello world. So with GoOS WASI-P1, we get all the basic functionality of the WASI P1 specification. And then through those packages, which are implement extensions to this specification, we can get kind of full networking capabilities like any native Go application when compiling to WebAssembly. And that concludes my little presentation. Do you folks have any questions?
Awesome.
I posted a link to just a package that we wrote that just builds on top of everything that Ashil mentioned to
nice.
To basically like the couple of things like around like file system and executable dir and netlisten and style context. And with this package, that's it in its entirety. We were able to rewrite our entire, or have our entire like program, like service run under WASI P1 with WASI run.
Well, that's very cool.
Yeah, it's really small. It was really nice to use.
That's really nice. Yeah, so you've got, so you're using build tags to select like either a native or a WASI P1 version of your API.
Yep. Yeah. If you want to just grab this and put it into the WASI P1 package and just wrap it in build tags and just expose that so programs can use it without having to have different versions of their code, you're more than welcome to.
Yeah, this is like a very useful, I want to say trick, but like capability. So applications that target WASI P1 or target native, or they target both native or WASI P1, often have to use those build tags to kind of like specify which version of the some pieces of code need to be included in the binary. So we use this a lot in this net package, and this is another example of how to use it. Bailey, you had a question.
Yeah, is the idea to upstream some of the WASI P1 package piece into upstream Golang, or is that not possible?
I think for the main Go, also, I don't know, Johan, if you want to jump in and
No.
okay. For the core Go language, we're probably not going to include extensions because we want to, stability is the main requirement. So WASI P1 is the interface that is portable across all runtimes, and it's also the interface that's stable and isn't going to change. So extensions, at least this is kind of like the stake we're taking, is we're not going to include those network extensions directly into Go. However, what could be interesting is Go has this XNet package, which is kind of like an official library for networking, packages that don't get included in the standard library, but are often useful to a lot of applications. So an idea we have is to take this, once we've kind of battle tested those libraries as this external package, can we promote them to XNet and make them kind of like give them more visibility that way? But those will not go into main Go. I think for full networking capability in Go that integrate with 100% of the standard library, we'll look at WASI Preview 2 and all the definitions that come with the component model.
And on that note, I haven't diffed the extensions with WASI Preview 2. Is there anything that's not in the WASI sockets proposal right now that doesn't match these extensions?
That's a good question. I have not looked carefully enough into the WASI Preview 2 proposal. I think for a while there was discussions of not allowing DNS resolution from the guest, which would definitely be a problem here. But we'll have to I'll have to take a closer look at it, and I can give you an answer.
What would the mechanism to even prevent DNS resolution from the guest be anyway?
That's a good question. Because if you connect from TCP sockets, you can do DNS resolution. Yeah, I think it's again, that would be like the difference between do you prevent it or do you make it really hard, and therefore you still need to customize your code in order to be able to do it. So I need to definitely look closer into this.
Yeah, I know we're planning to advance that proposal really soon, so I wanna make sure that it captures what Go needs.
Yep, it's a good call out.
But this is great. I think it's really awesome. I plan on building stuff with it now. Basically while I'm on this plane.
Perfect. Well, if you have any feedback or you run into any bugs, please reach out.
Hey, Ashil, I have a question. So for WASI P1 target, because WAS and GC isn't stabilized, so the current way that a Go module compiled to a WASA module, is the whole runtime also bundled into that WASA module?
Yes. Yes. So in Go, you get like 100% of the language works when you compile to WASM and WASI P1. The entire Go runtime gets compiled in the module, so it creates modules that are a little bit larger than typical WASM module, I want to say, which they're more, I think, targeted towards like server workloads. At least for WASI P1, this is what we're targeting mostly, right? So the size, whether you've got something that's like 50 kilobytes or 1 megabyte on the server side, it doesn't really matter much. I mean, some people might disagree, but for my use cases, the size is acceptable. And so you get the GC, like the Go GC is built in. It does garbage collection. You get Go routine scheduling, and with even if there's just one thread, right, in WASM today, you still can do preemptive scheduling of the Go routines where they will yield to one another to allow for concurrent executions.
Sounds good. Thank you.
Cool. What else do we have on our agenda for today? Oh, should we talk a little bit about with Bind and Go?
Yeah, I can kick this off. Although I haven't done too much work on the Whip Engine Go, the only thing I've done is with Randy on the WASM tools. We have a repo we have a PR to emit the Whip parser into a JSON format. And Randy I believe you're working on a Whip Engine Go in pure Go to consume that JSON format and build a AST out of it.
Yeah, I haven't worked on it a ton since last week because I was at WASMCon and then I had a busy weekend. But I'm gonna pick it up. It was fun learning Rust to work on that pull request to do the JSON serialization. It made me wish that there was a SIG package for Go because Go's JSON like decoding and encoding leaves a lot to be desired. Especially if you're doing any kind of like polymorphic, like encoding or decoding of like, things that like quack like an enum or like a tagged union. You have to jump through some hoops. That's been a journey. So I should have something to show, like hopefully by the next Go SIG call.
Yep. Just a PSA. I will be OOF starting tomorrow. Flying back to China to visit my family finally. And at the end of September, I will be attending KubeCon China in Shanghai. That will be a 1-week trip to Shanghai. And then I will come back to Vancouver for work in October 15th. So it'll be about roughly a month. Not be able to see you guys.
You'll be missed, but it's good to visit family.
Yeah. Joe, are you planning to go to WASM Day in Chicago? That I believe is November 6th.
Yeah, early November, right? I will be there. Oh, we probably can talk about what to show off in the WASM Day at KubeCon. That will be November 5th to 8th. Maybe I got dates wrong, but roughly around that time.
Yeah, I just posted a link to it. It's November 6th. I don't know if the entire schedule has been announced, but I know that some speakers have been contacted. So like the keynote crew at least. I think we'll keep getting a few more scheduling updates. I'm not on the program like I was for WASMCon. So I can't answer any of those questions, but I think it's going to be a good set. I'm pretty excited, especially with what I just saw here. I think very much in the cloud native space, it's more Go than it is Rust. So having all of this together is going to be really important.
Joe, is this the conference where you're speaking at next, or is it a different one? Yeah.
For those of you who don't know, I have a lightning talk accepted to WASM Day of KubeCon NA in Chicago, starting November 6th. And that lightning talk is about 5 minutes. So I'm going to pack a bunch of stuff into that talk. Probably I will cover the Go YZP1 target and some of the work we are doing in this subgroup, including Weibanzheng Go, and probably the way how we can create Wasm components from Go programs today.
Yeah, we did a lot of discussions at WasmCon about all the ways that all the tricks that we're gonna have to play to make the current ABI of the component model work with Go. It's gonna be an adventure.
Yeah. David told me Go has a plugin system, so you can write Go plugins without having to define a main function. So that compiles to like a dynamic library, like a DLL thing.
Yeah, there's a bunch of compilation mode. You can build like shared C libraries or static C libraries, like in Go. I don't know, like, oh, so you mean like to build like a component that could be like a different compilation mode where there's no main, and then yeah. I think, Johan, this is kind of something we've discussed before. Also, you know, the discussions around how to implement WASM export, and you know, how like how does it make sense in the context of a Go application? Yeah, it's probably going to be something like that eventually.
Got it.
It might make sense to create a milestone, either in the Weibanzheng repo or in the Bytecode Alliance top level, for all the things that we need to get done before KubeCon, including Hackery for the component model. If there's anything that I can help, you know, get other folks to swarm. Jordan Rash, for example, isn't here right now, but he would love to help contribute. And I know a few other people I can reach out to. So if we enumerate everything through GitHub issues and what needs to be done, I think we could make a lot of progress by November 6th.
Yep. My next step on the Go component model work is going to be to write a documentation about everything we've learned about how memory management works in the component model, and how like how we can turn this into a proposal of what to add to Go, because it feels like it's going to be a little bit of a blocker, because that's the bottommost cornerstone of being able to create everything. Like, you know, all the code generation will depend on this, and all interaction between the guest and the host. So that's kind of what I have on my radar.
Right.
It'll be interesting to see if TinyGo needs any changes as well. I mean, we expose a lot of internals, so we might be able to get away with it, but
yeah, TinyGo is like somewhat accidentally lucky here, because its usage of LLVM and libc means that they get all those features, you know, kind of for free. Though I'll talk to you more about it, Damon, but I'm more like, I have questions about how the GC works in TinyGo and how they deal with a lot of the complexity that we'll have to deal with in Go.
that's good. I fixed a lot of bugs in the garbage collector. I can tell you lots about TinyGo's garbage collector.
Perfect. Yeah, it's more than a 5 minutes conversation though, so. Cool. I think this was everything on our agenda. Does anyone else have topics they want to bring up to the discussion today? All right, in that case, don't forget, we're launching this blog post tomorrow. I expect all of you to share it, and with anybody that might find it interesting. And we'll talk to each other in 2 weeks, except for you, Joe. Have a good vacation.
Thank you so much. See you then.
Cheers.